Hey gang, I want to talk to you real quickly today about interpreting remainders when you're doing long division. When you have a remainder, what you have is you have something that's left over after things have been put into equal groups. That's what a remainder is. Okay? So if we're doing division, we're taking a large amount of items and we're putting them into smaller equal groups. When that's done, if you have leftovers, that's what your remainder is. Okay? Now, what you do with that remainder and how you answer a question all comes down to what the question is asking in a problem. In a problem, you have statements that give you information, and then there's a question at the end, and that's the vital part for us to pay attention to. And that's what we're going to talk about today. One of three things is going to happen when you have an answer to a problem. Okay? If you have a remainder in your answer, let's say you do a division problem and you get 29 with a remainder of 6. Okay, let's say that's your answer. Okay, well, what that means is, and it's important that as you do a division problem, you know what all of your numbers mean in the problem. We're going to talk about that as well. If you have 29 with a remainder of 6, that means you have 29 completed groups. If you were making smaller groups of a certain number, you were able to do that 29 times. Okay? Then you had some that were left over. You weren't able to make another group, and you had 6 that were remaining. Okay? So your question at the end of your problem is going to ask something like, how many total groups did you make? Well, or how many completed groups did you make? Well, that answer would be 29. It might ask how many would be left over. Well, that answer would be 6. But sometimes you get a question that asks something like this. Let's say that these are 29 boxes. Let's say you had crayons and you were putting them into boxes, right? Each box held 8 crayons. So we did a division problem where we were dividing by 8, and we got 29 with a remainder 6. And the question wanted to know how many boxes would you need to hold all of the crayons? Well, 29 boxes would be full, but would we have put all of the crayons away? No, we would have had 6 left. They would need to go in another box. So your answer to that question would be 30, and that's not a number that's in your problem. Okay? It's going to be one more than what you got because we need to put those remainders in that extra box. So as we go through this today, pay attention to what I'm asking you. Okay? Pay attention to what I'm asking you and pay attention to the numbers in your division problem so that you know what they mean. And then we're going to look at the questions and say, all right, how do we answer those questions? All right? I've only got 2 problems to go over with you. Okay? So it won't take long. Let's take a look at the first one. All right, first of all, anytime you're reading any kind of math problem, there's 4 things that we can do, right? Add, subtract, multiply, and divide. You've got to know what the difference is in those things, okay? When we're adding, we have an amount, we're taking another amount, we're putting it with it. That's addition, okay? Subtraction, we have an amount, and we're taking some of it out. That's subtraction. Multiplication is when you have a certain number of groups and there's the same thing in each group. 6 groups and there's 9 there, there's 9 there, there's 9 there, there's 9. You were counting by the same number over and over. That's multiplication. Division is when you have a large number and you're going to make it into smaller groups that are equal. Okay? We have a big number, 186, and we're going to put them into groups of 5, 5, 5, 5. And we're going to take away each repeated subtraction, right? That's division. Okay? So we have to be able to read a problem and decide, are we adding, subtracting, multiplying, and dividing? That's the first thing we've got to do. So here's my problem, and you may be hard to see. The markers aren't real dark, so do the best you can with it. Listen to what I'm telling you. Miles has 206 apples. He puts the apples into bags. Each bag holds 8 apples. Now I don't have a question yet. I have 3 questions here, and they're all different. We're going to talk about that in a minute. Let's go back to the problem. He has 206 apples. There they are. They're in front of him. He puts the apples into bags. Okay, he's going to start putting them into bags. Each bag holds 8 apples. So he takes the first bag, what goes in it? 8 apples. Next bag, what goes in it? 8 apples. Next bag, what goes in it? 8 apples. He's taking 206 and he's putting it into smaller groups of 8. That's division. Okay? So we're going to start by doing 206 divided by 8. Now, if I do my division differently from your teacher, I apologize. I may do it a little different. I don't know. Okay? We're going to start here in the hundreds. We have 2 hundreds. Can I count by 8s and get 2 or get close to 2? I can't. As soon as I say 8, I'm more than 2. So I can't divide the hundreds into groups of 8. So I'm going to put an X over that hundreds place. Okay? I can't divide the hundreds. Now I'm going to make my line a little longer. I'm going to break those hundreds into tens, add them to the tens I have. Now I have 20 tens. And I'm going to divide those by 8. When you count by 8s, do you get 20? No, you don't. So get close to 20. What gets you close to 20 without going over? 8, 16, 24. Nope, 24 went over. 16 got me close. And 16 is 8 times 2. So now I've got my 20 tens here. 16 I'm going to take away. I need to borrow and regroup. 10 minus 6 is 4. 1 minus 1 is 0. I have 4 tens that are left. I can't take 4 tens and put them into 8 groups, right? I'm divided by 8, yes. I can't put 4 tens into 8 groups, right? So I'm going to have to break them apart into ones and bring down the 6 ones I have. Now I have 46 ones. When you count by 8s, do you get 46? You don't. I hope you know your multiplication facts by now, because we've been harping on that for a long time. You don't get 46. Get close without going over. Think about your times 8s. It's 40. And 40 is 8 times 5. We're going to subtract again, and we have a 6 down here. Now, there's nothing else to bring down, so we're finished with our problem. This 6 is our remainder. So, when we divided 206 apples into 8 groups, we got 25 remainder 6. Well, that's great. That's your math answer. Now we've got to answer questions from the problem. Now you have to go back and answer what they're asking you. But before we do that, let's take a look at the numbers that we have. And I want to ask you some questions. What's 206? What is 206? Go back to the problem. What's 206? It's the number of apples that Miles had, right? This is what I'm talking about. You have to know what your numbers mean in the problem. 206 is the number of apples he has. What's 8? 8 is how many can go in a bag. He had 206 apples and 8 go in the bag. What's 25? What is 25? When we did this division, what is 25? 25 is the number of times he filled the bags with 8 apples. That's how many full bags he had. What's 6? 6 is the number of apples that are left there that he didn't put in a bag, right? They're the ones that are left on the table because they won't complete a bag. Now let's take a look at the questions that I have up here, because I've got 3 different questions. They're going to give me 3 different answers from this same math, okay? The first question asks, how many bags will Miles fill completely? Completely means there's 8 apples in the bag. Well, which of these numbers is the completed number of bags? It's 25, right? 206 divided by 8, we got 25. We'll be able to do that 25 times. So that answer would be 25 bags. He's able to fill them completely, 25 bags. But if my question was different, if my question, same problem now, if my question said, how many apples are left over? Well, after he does his division, how many apples are left over? That's the remainder. Now my answer is 6. Same problem, different question. You have to pay attention to the question. See what it's asking you. Okay? Same math, different answers, because they ask a different question, right? How many bags does Miles need for all of his apples? Ooh. He wants to put all the apples in a bag. Well, when we did the division, we had 25 full bags. We had 6 apples that were left, but he wants those in a bag. They're not, what bag are they going to go in? Which numbered bag? I got news for you. The answer's not up here. This is where you have to think. How many bags are full? 25, right? These are the number of full bags. Those have to go in another bag. Will they fit in one bag? Yeah, they will, because how many apples can fit in a bag? It's in the problem. How many apples can fit? 8. We only have 6, but they're going to have to go into bag number what? They're going to have to go into bag number 26. 25 of them were full already. We're going to need another bag, and if we had another bag, right, it's going to be bag number 27. 6. There's no 26 up here in our problem. We have to understand that we needed one more bag from what we had. We had 25 full ones. We needed another one to make it 26. That's where these 6 apples are going to go. How much room will be left in the bag? How much room will be left in that extra bag? Room for 2 apples, right? If you understand what we're talking about, there'd be room for 2 more apples in that bag. Okay? So, the division is the same no matter what your question is. But when you get to the end, you have to know what your numbers mean. Make sense? Let's do one more problem, then we're going to be done. There are 89 people in line to ride the Mind Bender. Ah! If you're a ride person, you might get on a ride called the Mind Bender. All right? The ride can hold 7 riders at a time. All right? Let's stop there before we get to the question. There are how many people in the line? 89 people. Okay? It must be a good ride for 89 people to stand in line to ride it. Okay? How many people can get on it at one time? 7. So as those 89 people are standing there, they're going to start taking them in groups of 7. 89 people. Group of 7, group of 7, group of 7. Okay? What is that? What math thing? It's division, right? Okay. So we're going to have to do the math problem. 89 divided by 7. 89 divided by 7. Let's start with the tens. Can I take 7 from 8? Can I get, if I count by 7s, can I get close to 8? Yes, I can. I'm going to get 7 down here, and that's 7 times 1. I can take 7 from 8 one time. I'm going to subtract 8 minus 7 is 1. I have 1 10 left over. Well, I can't take that 1 10 and put it into 7 groups. Okay, so I'm going to break it apart into ones. I'm going to bring down the 9 ones that I have. And now I want to see, counting by 7s, if I can get close to 19. Do you get 19 if you count by 7s? You don't. So get close. 7, 14, 21. 21's too big. Go back to 14. 14 is 7 times 2. We subtract, we get 5. There's nothing left to bring down. 5 is our remainder. So the math for this problem, math-wise, my answer is 12 remainder 5. But 12 remainder 5 doesn't answer questions in a problem. We have to know what these numbers mean. Okay, so let's take a look at the numbers that we have in this problem. Let's start with 89. What's 89? 89 is the number of people standing in line, right? 7. What's 7? 7 is the number of people that are going to get out of the line, get in the ride, and go, right? So they're going to take the 89, they're going to take them in groups of 7. What's 12? What's the 12? That's the number of times the ride went when it was full. Good. When the ride was full. They were able to take 7 passengers on the ride, right? 7 riders. They did that 12 times. What's 5? It's the number of people still standing in line waiting their turn, right? They're waiting for their turn. They're the last 5 to go, okay? So did they take everybody in those 12 turns? No, they still had 5 people left, right? Now let's look what the question is asking. How many times must they operate the ride so everyone gets a turn? How many times do they have to do the ride so that everybody goes? Did everybody go in the 12 turns? When it was full, did everybody get a turn? No, we still had 5 people left, didn't we? So they're going to have to operate the ride how many more times? Once, right? How many people can go on the ride at one time? 7. How many people do we have left in the line? 5. They can all go on that last time. Turn number what? They did 12 already when it was full, so they're going to have to go how many more times? They're going to have to go one more time. So that's how many turns altogether? 13. These people are going to go on ride number 13. That's going to be the answer to the question. If they operate it 12 times, it doesn't take everybody. They're going to need to do it 13 times. Okay? If they asked how many times was the ride full, the answer would have been 12. How many people are left standing in the line? 5. How many times do they have to operate the ride so that everybody goes? Now we've got to think, and we've got to know that it's one more than this, and it's going to be 13. Okay? I got a link with 4 problems on it. Okay? Click on the link. Try those 4 problems and see if you can work your way through. Now, some of the questions will be asking for the full thing. Some might ask for the remainder. Some might ask for what are you going to have to do for the whole group. You have to think your way through the question, all right? Work hard. I'm proud of you.